While the absolute measures are used to describe the spread within a single dataset, relative measures are specifically designed for comparing the variability between two or more datasets that might have different units, scales, or means, as they express dispersion as a unitless ratio or percentage. For example, consider a scenario where a professor wishes to assess the consistency of a small group of 7 students' performance using two very different metrics, their GPA and SAT scores. Since SAT scores and GPA operate on different scales, a direct comparison of their absolute spreads can be misleading. Therefore, we will use relative measures of dispersion to compare the students' performance consistency across these two metrics. Let's start with the coefficient of variation. If we divide the standard deviation of the sample data by its mean and multiply it by 100, we get the coefficient of variation, which is the ratio of the standard deviation to the mean, expressed as a percentage, and serves as a standardized, unitless measure of dispersion. This value allows us to compare the variability between datasets with different units or scales. To begin, calculate the mean for each variable by averaging the sample data. Then, use this mean to compute the sample standard deviation, which is the square root of the average squared deviation of the data values from their mean. Once these two values are determined for each variable, divide the sample standard deviation by its respective sample mean and multiply it by 100. The GPA scores shows a higher coefficient of variation compared to the SAT scores. This indicates that, relative to their respective averages, the GPA scores show greater dispersion or less consistency among the students. However, the coefficient of variation has limitations. It cannot be used when the mean of a dataset is 0 or very close to 0, nor is it suitable for interval data, which lacks a true 0 point. To quickly compare the relative dispersion between datasets, especially when a rough estimate is sufficient or data is limited, the coefficient of range can be used. It is calculated by dividing the range of the dataset by the sum of its minimum and maximum values. Its value ranges from 0 to 1, where values nearer to 0 suggest lower relative dispersion, and values nearer to 1 indicate higher relative dispersion based on the extreme values. Now, identify the smallest and largest values for each dataset, then, insert them into the coefficient of range formula. The coefficient of range for GPA is slightly higher than for SAT scores. This indicates that, based on their extreme values, GPA scores show slightly greater relative dispersion or less consistency among students than SAT scores do. Similar to the coefficient of variation, the coefficient of range is useful only for ratio data, as negative values can misinterpret its meaning. Additionally, it is highly sensitive to outliers, as its calculation depends entirely on the extreme values. The coefficient of quartile deviation, which focuses on the central 50% of data, is calculated by dividing the difference between the third quartile and the first quartile by their sum. This measure is particularly suitable when the distribution of the data is skewed or contains outliers, as it is less affected by extreme values. To calculate the coefficient of quartile deviation for our dataset, first sort the data values in ascending order. Then, calculate the first and third quartiles using their respective formulas. Finally, insert these quartile values into the coefficient of quartile deviation formula. The coefficient of quartile deviation for GPA is slightly higher than for SAT scores. This indicates that, based on the middle 50% of the data, GPA scores show slightly greater relative dispersion or less consistency among students than SAT scores do. Similar to the coefficient of variation and coefficient of range, the coefficient of quartile deviation is useful only for ratio data, as negative values can misinterpret its meaning. The coefficient of mean deviation is calculated by dividing the mean absolute deviation by the average. However, the median or the mode can also be used depending on the specific analytical interest. When using the mean as the central tendency, first compute the mean for each variable by averaging the sample data. Then, use this mean to compute the mean absolute deviation, which is the average of the absolute deviations of the data values from their mean. For our datasets, the coefficient of mean deviation for GPA is slightly higher than that for SAT scores. This indicates that, on average, GPA scores show greater relative dispersion or less consistency among students compared to their SAT scores. Being a ratio, the coefficient of mean deviation is also not suitable for interval data. Join me in the next video, where we'll discuss measures of dispersion for the categorical data.